One of the main uses for computers today is the Internet. So what exactly is the Internet? To understand the Internet, we first need to review the computer. At the heart of the computer is the CPU, the central processing unit. The CPU controls everything. It fetches the input, it writes the output, and it manages the memory. The work of the CPU is managing numbers. It calculates with numbers to achieve the desired results. The numbers used in our current computers are binary numbers. What are binary numbers? Our usual numbers are decimal, base 10. They use 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Binary numbers are base 2. They use only 2 digits, 0 and 1. In our number system, each digit represents a place. In decimal numbers, the places are powers of 10, 1, 10, 100, 1,000, and so on. In binary numbers, the places are powers of 2, 1, 2, 4, 8, 16, 32, and so on. For each digit that we add, the numbers grow as seen in the table. A single binary digit is called a bit. A group of 8 bits is called a byte. So a byte is a number between 0 and 255. Binary numbers are difficult to read, and the relation between decimals and binary is complicated. A convenient compromise is to use hexadecimal numbers. Hexadecimal means base 16, so we're going to need 16 different digits. We use the digits from 0 to 9 plus the letters A through F, giving us 16 different symbols. Using hexadecimal numbers, we can write all byte values with at most 2 digits, from 0 to FF. Inside the computer, we measure memory by the number of 1-byte numbers that we can store. If we store 1,000 bytes, we call that a kilobyte. If we store 1,000,000 bytes, we call that a megabyte. 1,000,000,000 bytes is a gigabyte, which is about the size of our current computer's memories. Terabytes can be found on bigger storage devices. What if we want to store something other than numbers? Well, we're just going to use numbers. Text can be stored by using, for each letter, we just use 1 byte. The alphabet has 26 letters, so 256 numbers are enough. What about Japanese text? Japanese uses kanji, and there are a lot more than 256 kanji, so 1 byte isn't going to do it. So what we do is use 2 bytes for each letter. 2 bytes gives us 256 times 256, 65,000, which should be enough. If we use numbers in this way, we need to decide which number will be used for which letter or for which kanji. This is called encoding. There are many ways to encode. One of the first, which is still used, is ASCII encoding. It uses only 1 byte, and it works well for English. In ASCII, the letter A is encoded as the number 65. Many Japanese systems use Shift-JIS, but there are other systems too. If we encode using one system and then decode with a different system, we're going to get a mess. This is called Mojibake. Now countries have agreed to use one set of characters for encoding. This set is called Unicode and includes letters and characters for all languages. The most popular way to encode Unicode is called UTF-8. It can encode all languages and avoids Mojibake. Let's review different kinds of encoding. First, ASCII. ASCII is a 7-bit encoding with a total of 128 code points. The table shows how ASCII encodes some of the important characters. Next, let's look at UTF-8. UTF-8 actually includes ASCII as a subpart. Its main feature is that it has variable size. Characters can be 1, 2, 3, or even 4 bytes long. The table shows some examples of how UTF-8 encodes characters. In total, UTF-8 allows for more than 1 million different characters. Next, we're going to look at networking. A network is what we get when we connect many computers together. In a network, we connect 2 or more computers together. For this to work, the computers will need to understand each other. This means the following things. First, they'll need a way to recognize each other, called an address. Since we will have more than one CPU working, we need rules about who is going to be the boss. These rules are called the protocol. If one computer is faster than the other, the faster one is going to have to wait. And since a computer does nothing when it waits, we need to do something. To avoid this, we break the information into small pieces called packets. The Internet has a set of rules for how computers can talk to each other. This is known as the protocol. The protocol for the Internet was developed in the 1970s and 80s. It's called the Transmission Control Protocol TCP and Internet Protocol IP, or TCP/IP for short. The IP version that we're using now is version 4, so this is called IPv4. But however, gradually it's being replaced by a newer version called IPv6. To allow computers to recognize each other, each computer needs an address. In IPv4, each address is a 32-bit number, or 4 bytes long. This means that there are about 4.3 billion different addresses, and that might seem like a lot, but in fact, we're quickly running out. This is one of the main reasons why the Internet is being switched to IPv6. In IPv6, their addresses are 128 bits numbers, so 16 bytes long. So, now that we have this Internet, what can we do with it? This is going to be our next topic. In 1989, Tim Berners-Lee proposed a system to allow sharing of documents through the Internet. His system implemented hypertext, which made it possible to connect documents using links. He also devised a schema for writing such documents called HTML, and a protocol for transferring them via TCP. He also created a browser for viewing and editing such documents. This was the beginning of the World Wide Web. On the web, our pages are going to need an address too. This is called a URI, or a Uniform Resource Identifier. URIs need to follow a particular pattern shown here, which always begins with a scheme. The best known schemes are HTTP and HTTPS, but there are many others. To see the pages on the web, we use a web browser. Some of the more popular browsers are shown here: Google Chrome, Microsoft Edge, Firefox, Opera, Safari, which is used on the Mac. Other browsers which were important in the history of the internet were Mosaic, Netscape, and Microsoft Internet Explorer. In summary, what's the difference between the web and the internet? Simply said, the internet uses TCP/IP to connect computers. The web uses HTML to connect documents.